Okay, again, some more average rate of change. Again, this will be slope in the future, but average rate of change. Now then, automobile gas consumption. Now we've all know that's been coming down over the years. But what I'm going to do is I'm just going to look at, say, between 1960 and 1990. So I'm going to look over 30 years. So I've got to find out what it is per year. Okay, so I can see, okay, 30 is going to go on the bottom. Again, per year. So there we go, the years on the bottom. Think of it like that. What's the average rate of change? Okay, gallons per year. I'm going to put the gallons on the top, the years on the bottom. Now what was it? How much did it go down by in those 30 years? It looks like it went down by, some minus, went down 148. Okay, so it went down by 148 gallons, okay, consumed per car over 30 years. What is that per year? Put that in your calculator. I think it comes back at 4.93, so about 5. Okay, about 5 gallons per year. Okay, so cars were using 5 gallons less per year. Okay, average gasoline consumed per passenger car. And so it's coming down by per year. Okay, we don't say 148 in 30 years. What is it per year? It's coming down. It's decreasing by 5 gallons per year. Okay, just for that 30-year period. Okay, so let's have a look at the next one. Chirping crickets. Right. Okay, again, as the temperature goes up by 5 degrees, the number of chirps goes up by 20. Okay, so it went up 20 chirps in 5 degrees. So how many chirps per degree? That's your average rate of change. Not 20 in 5 degrees. Can you see that's going to be 4 chirps, I'll put C for chirps, per degree Fahrenheit. Alright, it's like 4 cents. Okay, that's what it is. Again, it's just it went up by 20 chirps every 5 degrees. And actually, it is every 5 degrees. Look at this again. It went up by 20 in 5 degrees. 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 It's going up 20 every 5 degrees. So the average rate of change everywhere, not like some of the other ones which have been fluctuating, is 4, look at that, what I put degrees for, 4 degrees centigrade, is 4 chirps, okay, per degree Fahrenheit. 4, no, I'm going to write chirps, there we go, 4 chirps, okay, I know it's per minute, per degree Fahrenheit, okay. So that's what it is. That's the average rate of change because it's 20 every 5. It's 20 over 5. But that's everywhere. So this is a linear function. This is going to be a true straight line graph. Okay? It's going to go through every single point beautifully. All right? And that's why, okay, we are calling these linear functions because it has the same, a constant average rate of change, okay, everywhere. All right? So everywhere I looked, it had the same rate of change. It was 4 chirps per degree. That's right, yes. Now look at some of the questions. What's the possible practical domain? Remember, domains are the inputs. You can think of it as the x-axis. Well, look, okay. Well, for this one, it's 55 up to 80. But you could say, well, temperatures. Okay, well, I suppose I could go from 0 to 120. Does it get much hotter than 120 degrees Fahrenheit? I'm not going to put down 200. Nowhere on earth is it 200 degrees. Alright, so if you set fire to something. So the practical domain for this one, 55 to 80, you could go down if you want to. I mean, you could start at 0 degrees Fahrenheit. It's logical. Somewhere in Denver it's going to be 0 degrees. You get up to 110. Okay, those are the practical domains. Now, determine the average rate of change. We've done that. With respect to temperature, it's 4. Alright, because it went up by 20 for 5 degrees, which is 20 divided by 5, it goes up 4 chirps per degree. Okay?